Hi guys, how's it going? This is our very first video, and this one is all about 1.1. So chapter 1, section 1, that's what the 1.1 means. You'll see that almost every lesson we do is going to have two parts. There's the exploration part, and there's the notes part. The actual exploration part is all on you. This is where you need to follow the instructions that's on the page and work through these. Some of them are going to be pretty straightforward, like this one was. Other ones are not going to be, and you might have to struggle a little bit. The important thing to remember is that the struggle is good. We are here to struggle because that's what's going to make us better people and better mathematicians. The other thing to know is, that's for class time, right? That's when we should really be asking questions and working with our partner when it says work with a partner. The other thing I wanted to say is if you did this already and you worked with a partner, make sure you write their name up here. And if you haven't done it yet, when you do work with your partner, make sure you do that now. The next thing I want to say is you need to do the exploration before you can do the notes. We need to make sure that we have this part because this is the concept itself, and this is the notes of how we do it. And if we just look at how we do it before we know what we're doing, well, it's not going to make much sense, okay? So make sure we're going through this part first. This is kind of overarching big picture. This gets us into our nitty gritty. Over here we have our I can statement, and we want to solve one-step equations. That's our goal. The exploration you either have done or you're going to pause and you're going to do right now. Okay, now that everybody has done the exploration, we are moving on into our notes. You should have your note sheet that you grabbed from the back of the room. It looks just like this, 1.1 notes. It looks like this on the front of it, and then it looks like this on the back of it. We will do a couple vocab parts, then we're going to do a bunch of examples of each type, and then I'm going to show you a few more examples if you want. Actually, I'm going to show you where you can find some more examples. Your homework is posted in Clever for you to accomplish. This is just a link to that note sheet, the 1.1 step equations. That's this. Here we go with our vocab. I want to talk to you about what an equation is. I know it's a word you've heard before, but I want to talk about what it really means. Before I do that, though, I want to talk about an expression because equations are made up of expression. Expressions are simply just, they're like really short math phrases, right? They're things that have math in them, but never an equal sign. So, for example, 3x, that's an expression. It can be taken completely out of context, like 3x, like what's that even mean right now? That doesn't matter. That's just an expression. I could also have kind of a really complicated expression like 5x squared minus 4x plus 7 plus y plus is not equals. That's a really long expression. It's got a lot of different terms in there. Expressions also can be extremely simple. For example, I could have 9 as an expression. I could also have 0 or negative 32 or 34. These are all examples of expressions separated by the commas there. Equations are super easy when you know what an expression is. An equation is just it's a statement that takes two expressions and puts them equal to each other. So for example, I could say 3x equals 9. 3x equals 9. I took two of my example expressions and I set them equal to each other. I'm going to skip down here to solution. Now the solution is the number for x that makes this equation true. Well, what's that mean? X itself, we don't know what its value is when it just has an expression here. But now when we put in an equation, there is a solution. There's something that makes it true. What if I put in 5 here for x? I said this is no longer an x, now it's a 5. That makes this 3 times 5. I'm going to put a little dot in there to help me remember that those two things are multiplied. So 3 times 5, that's 15. Is 15 equal to 9? No, those are different things. So that tells me that that's not the solution to this equation. I know you guys can look at this and just know what it is. So you guys should know that it's 3, right? This is 3 times 3 equals 9. That gives me my solution. That is true. It's also important to note that 3 is the only number that makes that equation true. There's no other number you could throw in there that would make that a true equation. So a solution is a number that makes an equation true. Again, these notes are right there. You should be writing these in there. Our official, what we're going to say for an equation is a statement with an equal sign between two expressions. Statement with an equal sign between two expressions. Linear equation in one variable. It's kind of a long vocab word, right? The important thing to know here is it's a very specific type of equation. In math, there's like billions of different equations, and this is a specific type that we're going to talk about. So this specific type of linear equation just says that it can be written as ax plus b equals 0. So all the ones that we deal with can be written in this form where a and b are just numbers. Okay, inverse operations. This is bold because this is a big one. Inverse operations are just operations that undo each other. So think of an operation. For example, a gallbladder removal. So there's an operation, gallbladder removal. Then there's an inverse operation that undoes gallbladder removal, which would be like putting a gallbladder in somebody. Those are two things that undo each other. Another example of an inverse operation would be a stapler and a staple remover. They undo each other. In math, this looks like if I have a number like n, we don't know what it is, right? And I say n plus 5 minus 5. Well, what is n? We don't know. I want you guys right now actually to pick a number for n. Put any number you want in there. And then add 5 to it. And then subtract 5 from it. You should get n out. Those are inverse operations. They undid each other. What if I did it the other way around? What if I have n minus 5 plus 5? Well, if I have n and I take 5 away from it, then I add 5 to it, I'm still going to get n. So for example, if for me, what if my number is 2? 2 minus 5 is negative 3. Negative 3 plus 5 is 2. So they are inverse operations. This is our first pair of inverse operations. What's nice about inverse operations is that they always pair up. It's a long box. I didn't need one that long. So my inverse operations are addition and subtraction. And then the other inverse operation that we're going to talk about, the other inverse operation that we're going to talk about is if I have n, or even we could do any variable, c times 4, if I take that right there and then I divide it by 4. I get back to that c, that undoes each other, multiplication and division. Division undoes multiplication. Think of 4 as the stapler and divide by 4 as the staple remover. Same thing happens again. A d divided by 9,949, big, huge number, right? Huge number. I don't even know, is that 9 million something? Times 9,912,962. It's going to get us back to D. These are undoing each other. They're inverse operations. I don't even need to do the math. I just can see, well, divide by that number, then multiply by the same number. I'm going to get back to D. So the other ones that are inverse operations of each other is multiplication and division. Make sure we have these in there also, right? So addition undoes subtraction, subtraction undoes addition, multiplication undoes division, division undoes multiplication. Okay, these are nice to look at, but frankly, I don't think they're very helpful. We're going to keep moving. We're going to look at some examples now. So here are our examples. Okay, so now we're going to take a look at some examples that are just like your homework. Start with this first one here. We have x plus 5 equals negative 2. And we want to be able to figure out what is x that when I added 5 to it, it equaled negative 2. A lot of times we think that we're pretty smart, and we are, but sometimes our eyes will trick us, right? Because I look at this and I think 3, it's got to be 3, right? 3 plus 5, right? Or 3 minus 5, that would get us a negative 2. That makes sense. But wait, we can't just look at it and think that. We need to use our inverse operations. So I'm going to look at what happens to x plus 5. I'm going to look what happens to x. I see that it's plus 5, and I'm going to do the inverse operation. What's the inverse of plus? Minus. So I'm going to minus 5 from both sides. Go ahead and throw a line in there just to help us see it, okay? Maybe. All right, so there's a line between them. X plus 5, now I'm working my way down. X plus 5 minus 5. We don't need to know what x is to be able to do that math. Whatever x is, I'm taking whatever it is, and then I'm adding 5 to it, then I'm subtracting 5 from it. I'm left with x. Now I have negative 2 minus 5. That gets me a negative 7. It wasn't negative 3, or it wasn't 3. So my solution now, remember that vocab term, is negative 7. Negative 7 plus 5 equals negative 2. The next thing I want to show you is that we can always check our work. So you guys all have your laptops. You can go in here to your calculator, and you can check to make sure, did that work that I just do, did that make sense? Did I do that right? Let's see what happens when I plug in negative 7 here. So I'm going to take negative 7. Oh, so negative 7 plus 5. That did give me negative 2. I made this a true statement with my negative 7. Here's another one. The reason I chose this example is because I don't want you guys to get bogged down because of big numbers, right? It looks really big, but we just need to think, okay, what's the inverse operation? What's happening here is I have negative 55 times x. Where's the times? What are you talking about? When we have two numbers really close together like that, that means we're multiplying. So negative 55 times x. I need to undo multiplying. Oh, I'm going to divide so I can undo multiplying. So I'm going to divide by that number. Divide by negative 55. On both sides. Notice that we might, sometimes we might look at that and we think, well, that's minus 55. Well, it really depends on where it is, right? If this is here and x is right on it, that means I'm multiplying, so I have to undo it. I have to divide to undo it. This is a tricky one. Negative 55 times x divided by negative 55, notice the same number, they undo each other. That leaves me with x. Negative 110 divided by negative 55, what's that? Well, we might even need to use our calculator just to do this part, which is okay, right? We might be able to look at it and do it in our head, but if we have like decimals in there or fractions or things like that, it's okay to grab a calculator to do these, okay? So here I have, let me clear this out, 110, which is negative, divided by 55, which is negative. What do I get? I get 2. So even though this had that really big number, my answer is really 2. My solution is really 2. Here's another one. This one's pretty easy, so I want you guys to pause and try it on your own. So go ahead, pause. If you feel kind of confident with this, you can go ahead and pause and do all 3 of them, and then kind of skip ahead a bit. Right now, I want you to pause and do number 3 for sure. Okay, we are coming back now. How did it go? You feel good about it? What do we need to do here? Well, this is kind of like this one that we just did, and that this means 3 times x. How do I undo times? I have to divide again. The other tricky part was that our variable was on the other side here. Don't let that fool you. It's all about what's happening to the variable. The variable is being multiplied by 3. So here I'm going to divide by 3. And then I'm going to do the same thing to the other side. I'm going to divide by 3. 15 divided by 3 is 5. 3x divided by 3 is x. They undo each other. And we can check to make sure it works, right? What's 3 times 5? Gives me 15. That's true. I found the solution. Moving on with the next one. This is where we have these double negatives. If I say something, you guys may have heard this when you're in elementary school or even middle school. If I say, I'm never not going to the grocery store. I'm never not going to the grocery store. Anybody ever be like, well, that means that you're always going to the grocery store? Because you're never not going to the grocery store. The same thing happens here. These two negatives minus negative 3 cancel each other out to make a positive. So when I have never not, that's 2 negatives, and then it becomes a positive, is always going to the grocery store. So this can change right into k plus 3 equals 6. Now it's super easy and you guys can crush this. So I'm going to go ahead and subtract 3 because that's the inverse operation of adding 3. K plus 3 minus 3, k. 6 minus 3, 3. So I know k must be equal to 3 now. And always be ready to pop that calculator up there and check it, okay? The last one, we have a fraction. I know how you feel about fractions. You're like, wait, Mr. Meyer, they're just too hard. They're not, especially when you know that you have that calculator as a resource, okay, guys? Don't be afraid to use it when you get a little, even just a little bit tough. What I want you to try is to try it without the calculator, though, and then use your calculator. So here, first we got to think about what's happening. This is another one where I'm multiplying. See how they're really close together? So what I need to do is divide by 1/4. And I need to do that to both sides. Hopefully you're noticing that trend there, that whenever I do something to one side of my equation, I'm doing it to the other side of the equation too. One-fourth times x divided by 1/4. Well, that's just going to get me back to x. 9 divided by 1/4. 9 divided by 1/4. Any guesses? Take a second. Guess. We get. We're going to punch it in here. 9 divided by, and then I'm going to put this part in parentheses, 1/4. Put that in parentheses because sometimes our calculator might get mixed up. So now if I look up here, it's showing me 9 divided by 1/4. 36 is the answer. Whoa, 36? Are we sure? I don't know if we're right about that. We better double check. If I cancel out of my calculator. Now I take my 36 and make sure it's a solution. So 1/4 times 36. I do get 9. That is true. That's how that worked. I multiply by a fraction, and it gets to be a smaller number. Okay, if you're ready to tackle your homework, if you feel good about it, go for it right now. You don't even have to watch the rest of the video. But if you go work on your homework and then you're kind of like, then come back, watch the rest of this video. It's just a couple more examples with me walking you through it, okay? All right. Crush it. Believe in you. Remember, it's in clever. Okay, thanks for sticking around to get a little bit more help here, guys. I'm here to help. I want you to be asking me questions in class, but maybe you're at home right now, maybe you're in class, and you just want to try and figure it out on your own here. I'm all about that. That is a very important skill to be able to do. So here, the other examples that I have for you. I have x plus 3 equals -4, and the rest, I'm not going to read them all, but I want you to try them right now on your own, especially 1 and 2. Tackle 1 and 2 for me. And then come back and we will talk about just those two, okay? Tackle 1 and 2. I'm going to make sure you pause it though so you don't see the answer. Okay, so hopefully we looked at this and we thought, you know what? Something has to happen here. I've got x plus 3 equals -4. We need to make sure we look at this and we think, what's happening to my variable? My variable is having 3 added to it. So I need to go ahead and subtract 3 because that's the inverse operation of adding 3. So I should have in this box here -3. And if I do it to this side, right, I need to do it twice. So I'm also going to do it to the other side. Now if you look here, I've got this black line to help us so that we can see that we are on either side of the equal sign, right? This line continues down. So now we're going to think mathematically, working our way down. X plus 3 minus 3. That has to be x. Then I'm just doing math over here. This is -4 minus 3. If I owe you $4, right? I am -$4. I owe you 4. Then I owe you 3 more than what I already owed you. I'm going more negative. That gets me -7. If you're ever concerned if that's the right answer, grab your calculator. Type in -4 minus 3. Another way to make sure that you're getting these right, plug it in up here. -7 plus 3. Grab your calculator. Should give you -4 out. Here for number 2, we have x minus 5. Well, what is the inverse operation of -5? It's add 5. So I do that to both sides. X minus 5 plus 5 gets me x. And then 12 plus 5 gets me 17. Again, check our answer. 17 minus 5 gets me 12. What's awesome with this section is that anytime you do a problem, you can check to make sure that you got it right. It's like when you're done with chapter 1, you can just be like, hey, There's that one. Oh, I plug it in. Yeah, it works, right? It works. Here, I wrote this one in a different way. This says x times 3. This one says 6 times t. It's just a different way of saying the same thing, right? Except for this is multiplying by 3, that one's multiplying by 6, right? But these are both multiplication problems that might just look a little different. What undoes multiplying? Dividing. So I'm going to divide both sides by 3. Times 3 divided by 3 gets me just that variable. And we'll get to a point where it's like we don't even need to think about this. Of course they undo each other, right? I know it's just going to be an x equals down here. Negative 9 divided by 3 gets me negative 3. Negative 3 times 9, negative 3 times 3 gets me negative 9. Here I'm going to divide by 6. I'm going to do that on both sides because I always do that on both sides. Every time I do anything to an equation, I do it to both sides. 6t divided by 6, they undo each other. That leaves me with t. Negative 6 divided by 6. That's going to get me negative 1. Let's say I'm not sure. I want to double check it. That's okay to do. So I'm going to type in negative 6. On a lot of the calculators, you have to hit the button, the number, and then tell the calculator that you want it to be negative. This plus minus is my negative here. So this is negative 6 divided by 6. I do get negative 1. I did it right. And I can always check by plugging negative 1 in here. What's negative 1 times 6? It's negative 6. Gotta move my line over. It got shifted. Ooh. Should be with my equal sign. Okay. I believe in you. If you can do this problem right here, this number 5, even if you struggled with the rest of it, if you can do number 5, you're right there, like seconds away from crushing the whole lesson, okay? If you can do this one, you can crush it. So take a minute, pause the video, do this one. Okay, x plus 5 equals 5. Same thing to both sides. Here's a minus 5 because I'm doing the inverse operation. Minus 5 here because I do it to both sides. X plus 5 minus 5 leaves me with an x equals, if I have 5 cookies and I take away all 5 cookies, I don't have any more cookies. I have 0 and I add 5 to it, I get 5. I am all about doing more and more and more of these examples with you if you want me to. Just let me know in class. Just be like, Mr. Maya, that video kind of, I don't know about that one yet. That's okay. That's what I'm here for. That's what class time is for. It's for when we struggle. Also, don't be afraid to go onto YouTube and Google one-step equations. And it's going to be a plethora of equations, right? One-step equations. Type in that I can solve one-step equations. It's going to be a lot of good information there. Okay, guys. I know this was a longer video, so don't be afraid to. Don't be afraid. They won't all be this long. Okay. Your homework again is posted in Clever. If you're someone who really doesn't like the computer, talk to me, and we can set something up where you can use just your book instead of doing that. So if you go into Clever, let me actually pull it up quick.